Hello everyone. The name of our project is Development of Solenoid Energy Storage System to maintain a stable current design. First, let me briefly introduce the background of this project. It is a response to the following problems that may arise in the existing grid. Among them, the most significant problem is the oversupply of voltage in remote areas during peak power consumption period and the waste of electricity during low power consumption period. These are the objectives of the project. The central objective is to design an economically viable spiral coil energy storage system that can be charged and discharged automatically. Here, the main circuit, switches, and the two kinds of converter will be introduced. Our projects need to meet the following requirements. Turn on the charging circuit for charging during the low power consumption period and release electric energy during the peak power consumption period. At the same time, the station of each switch are as follows. So this is the basic circuit of our system. Our system is mainly composed of the AC to DC converter, the storage and control system, and the DC to AC converter. Here is our AC to DC converter. This is a full-wave rectifier, which is used to convert the AC input into DC current. Resistor R1 is used to protect the circuit. The capacitor is used to stabilize the voltage. For the design of the switches, the single-chip microcomputer 89C51, the relay and the voltmeter are used. The three relays are used as trigger switches S1, S2, and S3, respectively connected to the P1.0, P1.1, and P1.2 interfaces of the single-chip microcomputer. For the DC to AC converter, it is mainly constructed by signal generators, diodes, field effect transistors, and transformers. The circuit on the left is used to convert the DC input into an AC electrical signal, then use the transformer to adjust the output voltage of the entire system to the required level. The third part is simulation. The last part is conclusion. Based on the simulation result, the system can realize energy storage and automatic charging and discharging with the change of external voltage. Thus, the project was successfully implemented. Thank you for listening. Now let me show you simulation of the design. The first thing to introduce is the simulation of AC to DC. This part of the circuit has been introduced in the figure above. Here is a sinusoidal AC with a peak value of 310 volts, and then it will be converted into the yellow voltage through this circuit. The DC voltage is 308 volts. Then we simulate the control circuit. We use 290 volts to simulate low voltage. When 290 volts voltage is connected to the circuit, the switch of RL1 and RL2 will jump to the left, and then the microcomputer will operate according to the code. Therefore, S1 and S2 are disconnected, S3 is connected, and the energy storage circuit is in discharge state. Similarly, 310 volts voltage is used to simulate normal voltage. 330 volts voltage is used to simulate ultra-high voltage, and the conversion between high, medium, and low voltage is achieved by connecting 20 volts voltage in series. During voltage conversion, S1, S2, and S3 will jump according to the table we have described above. So in this part, our simulation results are still very satisfactory. Finally, we want to simulate AC to DC. The voltage of AC is very stable at 25 volts. It seems that the conversion between DC and AC is very successful, but there are also some problems. That is, the DC will become zero in 5 seconds, resulting in the output AC will also become zero. Therefore, after discussion, we decided to increase the inductance of the energy storage circuit from 1000 to 5000 Henry so that the DC can be maintained for more than 10 minutes.